All right. So, Evan, for this week, we're looking at section 9.4.
How many more sections do we have in this?
9.5 is the last section. Okay, so section 9.4, in my opinion, is one of the easier sections in this chapter, because so far in this chapter we've seen how we've had multiple different ways of approaching the same problems. We've had problems where we have to use a formula with numbers. We've had problems where we have to use formulas with variables. We had problems where you had to create a picture to get the numbers to plug into the formulas with the variables. Like, those are all like intense processes. Plus, we've also had ones where it was like, now we have to do a proof with this information. Those kinds of problems, only 3 of them exist in this section. The numbers, the variables, and the proofs. There's no picture problems like we had last week, where we have to draw the picture and plug in information from the picture in Pythagorean theorem. So we're doing those this week. That's because these formulas by themselves tend to be the more basic formulas. They tend to be a lot more of the plug-in check ones. But I do want to point out that so far on our formula page, we have used now the entire formula page. Everything on it. These 4 sections encompass the entire formula page. We talked about even odd rules, which we will use today as well, some difference rules, or we call addition subtraction rules, quotient rules, reciprocal rules, half angle rules, double angle rules, and today we're doing the product and sum rules. So, as with previous sections, so far the first block said this was pretty straightforward, but I will say like the big thing about this section will be it's formula based. Same with the last section. If you can understand which formula to use, how to plug into that formula, and then can algebraically simplify using the rules we've established so far, then this section will not be too hard. If you struggle with finding the right formula, if you struggle with plugging into that formula, if you struggle with the algebraic and simplifying, or forget some of the rules, it may pose a little trouble. So let's look at number 2. Today, I wanted to focus most of our time on looking at examples. There'll be very little instruction. As I mentioned last week, we're going to be doing as many of the even problems as we can in class. We'll be skipping the even problems in the homework from now on, just looking at the odds. So we'll start with number 6. The problem states we have the following function. It is a product because we have 2 trig functions being multiplied together. And the instruction states, rewrite this product as a sum or difference.
Is that BT or
16. Thank you for asking that. Yes, it is 16. I wish they would stop doing that. Or we had a different letter that didn't do. So, most of your homework has very similar instructions. It'll say rewrite using blank. In this case, it's a product, because rewrite using a sum or a difference. Now again, the trick with these kinds of problems is you have to find the right formula, plug into that formula correctly, and then simplify that formula down to one solution. So I have listed the formulas. These are again on your cheat sheet. You have to write them down. I just listed them for my convenience up here on the board. We are supposed to take this product of cosine times cosine and turn it into a sum or a difference. To do so, which of these formulas are we going to use? Yeah, we got one right here. Cosine alpha, cosine beta. These are 2 things being multiplied, and they are equal to 2 things being either added or subtracted. So the first thing I got to figure out is which formula I'm going to use. The formula is as follows. 1/2 bracket cosine alpha plus beta, alpha minus beta, plus cosine of alpha plus beta. Now, this formula works for just the cosine times the cosine. That is all it is for. That is all it does. It does not have anything to do with the 20. So what I will also want to do is make sure that 20 stays in this problem by moving the 20 down with the rest of the problem. 20 times my formula. Again, the cosine times cosine gets replaced with our second formula from the product to sum rules. Now, in this problem, my alpha is going to be 36t. My beta is going to be 6t. What I'm going to do is I'm going to take that information, plug it into my formula, and I'm going to look to algebraically simplify this down to one solution. Now, important things as we do so. Note, all the rules we have in our list can be applied to these problems, as well as anything algebraically that you can do can be applied for these problems. Examples. In this case, 20 times 1/2. Well, that's just 10. Parentheses. Cosine. Alpha minus beta. So that would be 36t from the alpha minus 6t from the beta plus cosine. of alpha plus beta. So 36t from the alpha plus 6t from the beta. There's my problem. Once I've got them all plugged in, algebraic simplification is the name of the game. So let's simplify some stuff. I got a 10 out front. Cosine. Parentheses. 36t minus 6t. Well, that's 30t. Minus 36t plus 6t. 42t.
What do you mean plus?
Oh, yeah, thank you. I was totally like, it's a plus. What are you talking about? Thank you. All right. Now, first thing you note, I'm not quite finished because this is not currently a sum. It's a product still. It's 10 times some stuff. And those two things do not combine. So my last step, I'll distribute the 10 to each term. 10 cosine 30t plus 10 cosine of 42t. This is now a sum, and that means we are done. Woo, good lunch. So yeah, this is number 6. If you can find the formula, plug in the formula, simplify algebraically, it's not too bad. Just make sure. Yep. Oh my gosh, yes, sorry. I wrote that too quickly. Let me make that very clear. Mildly better.
What
All right.
page is it on in the book?
In the book, 737. Okay, let's look at number 8, which is very similar but has a unique finishing step that's very important. Here's number 8. So as you can see, if you can figure out the form you're supposed to be using, plugging into that form is not too hard. Simplifying that form is not too bad. The big thing is going to be figuring out the form, how to plug into it, and then simplifying it. So number 8, we have the following setup. 10 cosine of 5x times sine of 10x. There we go. So as you can imagine, these problems, plugging in the formula isn't bad once you have the right formula. But there is one final step that's kind of important. It needs to make sure to be written properly at the end. And in this case, properly indicates it needs to be a sum, not a product, for these specific problems. And that product, whenever it's finished, should make sure to be fully simplified. This one has a unique issue with it, which we'll talk about. Number 8. First, let's look at our list. We have a product of cosine times sine. One of our rules actually lets us simplify this into a new form using a sum. Which version of these rules are we going to use? Yeah, the bottom one, right? It says cosine sine. We got cosine sine in the problem. We're going to use that bottom formula. Now, as a reminder, the 10 is not included in the formula, so 10 will stay out front. We take the cosine and the sine, we plug into the bottom formula, which is 1/2 parentheses sine of alpha plus beta minus sine alpha minus beta. So in this case, my alpha is going to be 5x, my beta is going to be 10x. Once I have the right formula, everything else is just algebraically plugging in and simplifying. So let's do that. 10 times 1/2 would make this a 5. Bracket. Sine alpha plus beta. My alpha is 5x. My beta is 10x, so 5x plus 10x. Minus sine of alpha minus beta. My alpha is 5x. My beta, 10x. There's my new formula. The 1/2 got absorbed by the 10, becoming a 5. And the rest we're now going to start to simplify. That 5 out front stays a 5 out front. I'm not finished with it yet. So 5, bracket, sine. 5x and 10x together make 15x. Minus sine. 5x minus 10x will give me negative 5x. So 2 things to point out here. Number 1, this is not finished because it's not a sum yet. It is 10 or 5 times something. That is not a sum. So I need to distribute the 5. The second thing is that negative 5 on the inside is an issue. We do not want a negative on the inside if we can help it, so I'm actually going to use one of our rules from about 2 weeks ago called the even-odd rules. If you open that page, even-odd rules allow us to fix a negative on the inside by changing its location or removing it entirely depending on the function. Go to that page for sine. What happens to a negative on the inside? It goes to the outside. Now, what that means is this negative on the inside is going to move to the outside, but there's already a negative there.
It's supposed to get canceled and be a plus.
It's going to cancel and become a positive. From here, I distribute the 5 to both terms, and I write my solution. 5 sine 15x plus the double negative makes it a positive. The 5 distributes 5 sine of 5x. This is a sum because I have addition between my two pieces. Therefore, I've met the criteria of the problem. This problem is done. Now, from the beginning, Brian, I believe, recommended we use the bottom formula. That was not the only option we had in this problem. I want to go back to the beginning. Yes, ma'am. Yes. Very nice, Giselle. So from the very beginning, we have three things being multiplied. There's a rule in algebra which states that multiplication is what's called commutative, meaning you can change the order without affecting the outcome. Meaning we could have written this as 10 sine of 10x. You have to keep every piece the same. So the 10 is the same, the sine of 10x is the same, and then cosine of 5x. Because it's a different formula, we'd use a different version. We'd use this one instead, but it actually gets the same answer because it should. They're the same functions. So do note that there's often ways to simplify or rewrite from the beginning that could possibly make the problem a little easier. In fact, if you did that from the very beginning, Giselle, we would not have needed an odd even rule to finish the problem. And so like some experimentation, you might find that you can want to simplify some but not simplify others, or rewrite them. Like you have a lot of possibilities open to you now. Let's do one more of this type, now with numbers. So this is number 18. Nice sketch, Giselle. Very nice. 18. Again, you won't change the solution if you were to rewrite it, as Giselle recommended. You would just change the steps along the way. In the end, the same solution would appear. 18. We have the following information. Cosine of 45 times sine of 15. And the problem says, for number 18, evaluate the product using a sum or difference formula. Evaluate exactly. That phrase you're going to start to hear a lot more often in the next couple sections and in the final chapter of this book. Evaluate exactly just means don't use a calculator. It means use a unit circle or some other technique, but do not use a calculator unless it is like absolutely positively necessary. So, in this case, even without a calculator, I can at least do half this problem, but that's the issue. I can only do half. Cosine of 45 is on the unit circle. Like I could do it, but sine of 15 is not. That being said, we did find sine of 15 a few weeks back using a sum difference formula. We also found it using a half angle formula. There's still ways to find it, but for this week, we're going to use these rules. So, what we're going to do, we're going to take this thing which is currently a product. We have a cosine times a sine. We're going to rewrite it using one of our rules to turn it into, hopefully, two things that are on the unit circle rather than one thing that is and one thing that is not. Take a look at this problem and watch how I solve it. What we're going to do, we first recognize which rule we're talking about. It's cosine times sine. That is, again, the final formula. If I wanted to, just like with the previous one, I could switch the order. It does not matter for this one. So let's plug them in. The cosine times the sine becomes as follows. 1/2 bracket sine of alpha plus beta minus sine of alpha minus beta. From here, I plug in my two things. I have an alpha, that's 45 degrees, a beta, that is 15 degrees. And if I do this correctly, my results should have two pieces that are on the unit circle, which is my goal. Here we go. 1/2. That again. 1/2. Sine of alpha plus beta, so that'd be sine of 45 plus 15 minus sine of 45 minus 15. You'll notice that in front of you guys, I'm showing a lot of steps because this is for our notes. This is for practice. When I'm doing these problems on my own, I'm going to skip these middle 2 steps because I'm just going to go ahead and add them and subtract them in my head. So the next step would be what I would usually write down next. 1/2 bracket sine of 60 degrees minus sine of 30 degrees. The cool thing about what we just did was that both these pieces are in the unit circle, meaning I can do this by a calculator. Whereas in the previous one of them was, the other is not on the unit circle, so you have to do more work or rewrite. From here, I'm going to plug in for the unit circle and start getting to my final solution. That's good. From the unit circle, come over here. The 1/2 is still the 1/2, bracket. Sine of 60 degrees, I go over to my unit circle, I go to 60 degrees, I read the sine value, that is the y value, square root 3 over 2, minus sine of 30 degrees, that is the y value at 30 degrees, or 1/2. This is an okay solution, but I will go ahead and fully simplify it down to one big fraction. That's what the book does for a lot of them. I like this solution, I think it's good. But the book does simplify farther, so I will do that. We combine the two fractions together. Since they both have the same base, we get square root of 3 minus 1 over 2 as the inside piece. 1/2 still on the outside. Remember, if they have the same base, we just add or subtract the top, whatever we're supposed to do. And I'm going to multiply top times top, bottom times bottom. 1 times anything doesn't do anything, so we get square root of 3 minus 1. 2 times 2 would give us 4. This is what the book solution would be. They're both the same solution. Just the book likes to simplify all the way. And the calculator can help with those ones, especially if you don't plan on going any farther, like use the calculator if you need to. If you want to go farther, try practicing it. So again, this is what the phrase means when it says evaluate exactly. It means don't use a calculator, just use the unit circle if you need to, and rewrite the problem to make it work. I could not start this problem by doing what it said. I could not do cosine of 45 times cosine of 15 without a calculator. Instead, we rewrote it using a sum difference rule. And with that rule, we simplified until we got one solution. You might have noticed so far we focused on the top 4 formulas. The next couple examples are going to be using the bottom 4. So before we do, are there any questions over this first part? It's not too bad, but it's a lot of formulas. Brian? Brian, that is a great question that I hope all of us know the answer to, but otherwise some of you guys might be putting yourself away. You do not have to memorize all these formulas. Okay? You have to be able to use them and use them effectively. I'm not going to make you memorize all these formulas. That's ridiculous. Now, what I do tell people, if you want to take AP Calc, like take the AP exam, I tell them they have to memorize it. If you don't want to take the AP exam, then don't memorize it. It's not worth your time. Right? Nowhere in the real world has there ever been a time when you can't just look up the identity. Okay? It still annoys me that some tests still think that's a thing. Like, come on. But that is the case. So, you are not required to memorize those formulas. You're required to be able to use them. Now, some of them you will memorize just because you use them enough. Like reciprocal identities, I have all those memorized. Quotient identities, I've got those memorized. Some of the addition subtraction ones, some of the product, some of the half double. Even I have been doing this a long time, do not have them all memorized. I had to check mine. But again, like I can use them if I need to. That's the important thing to make sure. Let's look at the bottom list of 4. Now let's look at some examples using notes. Like a problem like number 12. Number 12. So these have the opposite instructions. The problems before have said rewrite the product as a sum. These ones will be rewrite the sum or difference as a product. Very similar questions, very similar steps, but the difference is the symbols in between. Number 12 says sine of 3x plus sine of 7x. We were tasked with rewriting this as a product. Now you notice that these formulas, the bottom set of 4, are a little more interesting. We got a couple more components to them. It's the same basic rules though. Find the right formula that matches the situation you are given, plug into that formula, get a solution. So, number 12. Look at the problem. I have a sine formula plus another sine formula. How are we going to plug into this function? Yeah, we got a sine alpha plus sine beta right here. So I'm going to plug into this specific formula. In this case, my 3x, that's going to be my alpha. My 7x, that's going to be my beta. And my formula says take 2 sine of alpha plus beta over 2 times cosine alpha minus beta over 2. So notice how it takes the sum of two things being added together, and then turn it into a product of two things being multiplied together, as long as I fill in the alphas and the betas. So let's fill in. My alpha, as it says, is 3x. My beta, as it says, is 7x. Let's fill in. 2 from the formula, sine alpha plus beta. So 3x from the alpha plus 7x from my beta, all over 2. Cosine alpha minus beta. So 3x minus 7x, all over 2. Again, and you guys, very smart people. You guys smart, so smart. Always amazed how smart you guys are. You probably wouldn't write down these first 2 steps if you do this problem on your own. You'd be like, oh, I'm just going to add them together and divide by 2. But do note, there are pieces of formula that the most commonly missed things are forgetting to divide by 2, using the wrong sign, it's supposed to be addition and you did subtraction, supposed to be subtraction, you did addition, like little things like that, believe it or not, are the most common problems. Incredibly common. And those things that are easy to fix if you know about them. And you check for it. Like they're easy to fix. But if you don't fix them, like suddenly you're in trouble. Alright, let's do this. So I now have 2 sine 3x plus 7x, that would give us 10x, divided by 2 would give us 5x. Times cosine 3x minus 7x would give us negative 4x, divided by 2 would give us negative 2x. Now, this is a product, but it is not a simplified product, so I'm going to take one more step, which is that negative. You have a negative inside of a cosine function. Even odd rules apply. What happens to that negative? It goes away. Remember, cosine and secant are 2 that the negatives inside have no effect on the problem, so they just go away. This is a solution. And for future reference, we are doing odds, so like you can obviously check the back of the book, but you can also just type the top equation into a graphic calculator and type the bottom one in, and they should be the same thing. Alright, question number 12. You can see like these ones from this section are very straightforward, like you just plug into formulas. A lot of the ones from the last section were the same thing. The tricky ones were the ones where you had to like build triangles and like use the unit circle a lot. There's not a lot of them in this section. In fact, the triangle ones, there's none in this section, which means this section is a little easier. Now, let's look at one more from the homework. In this case, this will be number 28, because this one also has numbers in it, no variables at all, but unlike with the previous one where they expect you to use a unit circle to get your answer, this one you really don't. Like, there's actually a good stopping place. The rule of thumb for this homework assignment and for future quizzes on this section, the rule of thumb is, if you can use a unit circle to simplify it, do so. If you cannot, stop. Just circle the answer. That's what I mean. Take a look at number 28. So the next problem, and probably our last problem. Do note for these problems, as we said just a moment ago, finding the right formula, plugging into the formula, and simplifying completely are the steps to take. Number 28. 28 says we have the following information. We have cosine at 58 degrees minus cosine at 12 degrees. Now, some of you guys are already starting some mental math. That's great. This problem will not end up on the unit circle. You do the math in your head real quick and check the formulas, like it will not end up on the unit circle. which is why the instructions are very specific. The instructions say, rewrite the sum as a product of two functions, leave in terms of sine and cosine. Meaning, if it's not on the unit circle, if it's like sine of 58 degrees, leave it at sine of 58 degrees. Don't simplify it any further. Here we go. So just like the previous ones, my first goal, figure out the formula I'm supposed to use. With that formula, plug into the formula, and then start simplifying as far as I can go. If it's on the unit circle, use the unit circle. If it's not, stop. That's it. Number 28, I have cosine of something minus cosine of something. I go to my formula list. That bottom formula is cosine minus cosine. In this case, my alpha is going to be 58 degrees. My beta, 12 degrees. So I plug in my formula. Formula says, this one has a negative 2 sine of alpha plus beta over 2 sine of alpha minus beta over 2. From here, I plug in. I plug in my alpha, I plug in my beta, and see what happens. I have negative 2 out front. Sine. On top, my alpha, 58 degrees. My beta, 12 degrees. All over 2. Sine. Alpha, 58 degrees. Minus beta, 12 degrees. I'm good so far. And then we just start simplifying. So this is going to be our last example, so you're okay. Just simplify as full and good as you can. Okay? I'll go ahead and get as far as I can while you're still here. So I get negative 2 sine 58 plus 12 is 70. Divide that by 2, I get 35, which is not on the unit circle, so I actually can't do anything with it. It will stay sine of 35. Over here, sine 58 minus 12 would give me 46. Divided by 2, that is 23. That is also not on the unit circle. I have my answer. It is in terms of either sines or cosines. In this case, 2 sines. That's fine. So, like I've gotten it from a difference to a product. Is it? If it is on the unit circle, plug in. If not, this section literally says to leave it in terms of sines and cosines. And notice you don't have to have both a sine and a cosine, just one or the other. Good luck, guys. Yeah. So, that's it. This section I feel like is going to be a nice refresher after the last couple. The last couple have been kind of draining. Yes. I would suggest if you're still missing some of those old homework assignments, this week should be a lot easier. Use the extra time that you're going to have to work on some of those old problems. Please do so. Review some of the old videos. Look at other people's versions of how they teach it. Maybe type in some different trig rules. Videos galore will show up. Alright? I promise there's somebody out there that does it better than me. That being said, the homework for this week is 5 through 53 odds. Today we have actually covered everything from 5 through 31. So you can get more than half homework assignment done tonight if you wanted to. And the second half, a lot of it can also be done. It's just kind of piecewise. So that is it for today. We have about 7 minutes left. Any questions before we finish?
Can I take the day off of school?
No. All right.